is Jalen Francis, and today I'll be going over a convolutional neural network I created that detects pneumonia in chest x-ray photos with a pretty high degree of specificity and sensitivity. So first off, I want to go ahead and give credit to Paul Mooney as I collected a data set from him. Um, as we can see here, we have testing data, training data, and validation. The training and data includes over 5,000 to train from. So yeah, I'll go ahead and demonstrate. So to start off, we are currently doing this with 3 epochs. Okay, now our model has currently finished training. As you can see, here's a plot just showing the training loss, the validation loss, and the accuracies over time. As we can see here, the sensitivity for this minimal training was 86%. So the accuracy of which it detects pneumonia in cases where the patient actually has pneumonia, and then the specificity, which was at 88%. So the rate at which, whenever a patient doesn't have pneumonia, how accurate are we? So now we can go ahead and demonstrate what the actual interface looks like. So these are 2 separate files, and this one loads the previous model built by the model.py file. And as we can see here, we can go ahead and upload images. This is just using the testing data, so we can go ahead and demonstrate. So we're going to go ahead and upload some normal photos. So yeah, it predicts normal, which is good. It's not 100% accurate, so as we can see, we went ahead and had one that predicted pneumonia, so we had a false positive. But as we can see, for the most part, it predicts normal correctly. And now for cases where patients actually have pneumonia, we can go ahead and see its predictions. And this also isn't perfect, so we might run into a case where it predicts normal. Looks like we're just getting lucky right now. Okay, yeah, there we go. We found a normal. So yeah, let's go ahead and let's go through the code and figure out how we can modify this, change the model. So first off, this is where all the work is done in the model.py file. We have our 3 directories in our assets folder, and these can all be downloaded in the README from Paul Timothy Mooney. The Kaggle link is there. So first off, we go ahead and load and pre-process the data. So we go to the directory, make it grayscale, and our label mode, since we have a classification problem, it's binary, so it's either pneumonia or not pneumonia. And for this, we went ahead and defined a custom loss because I really wanted to eliminate predicting pneumonia too much. And then here we can actually see our actual model. So here's all our layers. And then this is just thrown in there pretty much to help it become serializable for our actual custom loss function. This is a function that just plots out our actual loss. In our main, we go ahead and load all the data sets, we normalize them. We went ahead and build the model. So in our custom loss, we're actually using an alpha of 8. So essentially, modifying this number changes how much we punish the model for false positives. Here we have our early stop. So this is if we were to, use more epochs. Here we also have a class weight, so this also increases the weight towards normal. Yeah, to go ahead and fit. And this is where we go ahead and save the model. Save there. This is where we evaluate, get the accuracy. But then here we have a threshold, and basically this is what is able to collect the sensitivity and specificity ratings, because The overall accuracy doesn't mean a whole lot, especially since we have a lot more pneumonia photos than normal x-rays. So the accuracy is more so weighted towards pneumonia cases. Okay, and then over in our actual GUI, it's pretty simple. We just, load the model, prepare the images, we predict using a similar threshold, 0.8, function to actually open the image, load the model, and so on and so forth. So when modifying this model, there's two big constants that make a difference, and those are, if we go here, this alpha number. So this is where we can really change the punishments. So I've toyed around a lot with that. The threshold, that's something that you can change. So basically, how close it is to 1. So basically, we want to make sure the model thinks strongly if there's a pneumonia case. And then you can also modify the actual weights themselves. So overall, I'd say while this tool is not perfect, it goes similarly with doctors. So this is not to be used for any medical purposes. This is just a tool just to show how a neural network can help in the actual medical field. This code is all published in a GitHub that will be linked in the description if you want to find more. Yeah, so make sure, since I did not want to include all the assets into my GitHub repository, especially considering that it's a lot of photos and it's also not my data set. So if you'd like to run this, make sure you download the data set from here, and then you can go ahead and build your own model, make your own modifications to this model.py, and then once you build the model, you should be able to interact right away with the GUI. With that being said, that's pretty much all I had to share, and goodbye.